In this lesson, we're going to look at three-dimensional shapes. For our first question, we're given that this rectangle is rotated about side BC to form a solid. The questions are A, what is the name of the solid formed by this rotation, and B, what is the diameter of that solid? We'll rotate this rectangle using side BC as the axis of rotation. Since side BC is a vertical line, looking eye level at the solid formed will look like we are doubling this rectangle. If we could take this drawing and tilt it just a little bit toward us, it would look something like this. The shape being formed is a right cylinder. For the second part of the question, what is the diameter of the solid? Well, the diameter is going to be twice the width of the rectangle we started with. That gives us 24 plus another 24, or 48 feet for the diameter of our solid. Now let's take a look at another problem. This cylinder is sliced by a plane that is parallel to the base of the cylinder. What is the area of the cross-section formed by the plane intersecting the cylinder? To answer this question, we first have to figure out what the shape is of the cross-section. Since the cross-section is parallel to a base and the bases are circular, our cross-section is going to be circular also. And not only will it be circular, but it's going to be the same size as the bases of the cylinder. To help you picture that, let's take a look at what a cross-section might look like. This circular area here could be a cross-section as described in the problem. Again, notice that the diameter of the cross-section is the same as the basis, so it's 8 meters across. The only thing left to do at this point is to use the formula for finding the area of a circle and plug in the values that we've got. The formula, of course, is the area of a circle equals pi times its radius squared, which gives us pi times 4 squared, or 16 pi. And if we use 3.14 to approximate pi, we're going to get 50.24 square meters. Now let's take a look at another problem. This square is rotated about side BC to form a solid. What is the volume of the solid formed by this rotation? Now this question is similar to the first question we did in this lesson, where we had a rectangle being rotated using one of its sides as an axis of rotation. Just like with the first problem, we're going to get a right cylinder when we rotate this figure about side BC. Let's take a look at what that will look like. Picture spinning the square on an axis on BC like a swinging door that would go 360 degrees all the way around. This is the shape we're going to get. It's going to be this wide cylinder. It's going to be twice as wide as the square. We can see here that one of the relationships of the cylinder formed is that it has a radius of 8 meters. Now to find the volume of this shape, we just need to use the formula for the volume of a cylinder. The formula is the volume is equal to pi times the radius squared times the height of the cylinder, which gives us pi times 8 squared times 8, which gives us approximately 1,607.68 cubic meters. Now you know a bit more about three-dimensional shapes. See you next time.